Hi, today we're going to be learning about changing the dimensions of 2D shapes and the effect that it has on their area and perimeter. We're going to start off by investigating what happens when we double the dimensions of 2D shapes. In this activity, you're going to take the shape that you've been given over here and you need to calculate its area and perimeter and fill them in. Then you need to think about what would happen if you were to double the length of this shape and calculate its area and perimeter, and then compare the area and perimeter to what the area and perimeter were of the original shape. Then you do the same thing for if you double the breadth only, and then you do the same thing again for if you double the length and the breadth. I'm going to give you 3 minutes to do this. Okay, so let's go through that and see what you should have got. So first of all, you should have found that the area of the given shape was 100 meters squared and the perimeter is 40 meters. Then, if we take that shape and we double the length only, you're going to end up with a shape that's going to look something like this. And you're going to have 20 as your length and 10 as your breadth. So the area will be 200 meters squared and the perimeter will be 60 meters. Now, if you compare the area over here to what we started with over there, then you can see that the relationship between them is that 200 is double 100. So if we take the 100 and we double it, or we times it by 2, we will get this over here. The relationship between the 40 and the 60 isn't quite as straightforward. What we need to do over here is we need to add 20. Okay, so now let's have a look at what happens when we double the breadth only. If we double the breadth only, we'll end up with a rectangle that'll look something like this over here. So you're going to have 10 by 20 this way. Once again, the area is going to be 200 and the perimeter is going to be 60. And our relationships are going to be the same as we had over there. So if I double this, I will get this area. And if I add 20, I will get this perimeter. my area and my perimeter, when I double both the length and the breadth, giving me a shape something like this, is going to be 400 for my area and 80 for my perimeter. If I look at the relationship between the 400 and the 100, I need to multiply the 100 by 4 to get 400, and I multiply 40 by 2 to get 80. Okay, so that's what we should have got for that table. Now let's go on to the next one, where you're going to do the same thing, just you're working with this rectangle now. Okay, so I'm going to give you 3 minutes for this one as well. Okay, so let's go through that and see what you should have got. So first of all, you should have found that the area of this shape, 12 times 5 gives you 60. So that's 60 centimeters squared, and the perimeter is 34 centimeters. Then if we double the length, you should end up with a rectangle that looks like this. And then your area is going to be 120, and your perimeter is 58 centimeters. If we look at the relationship, from 60 to 120, we have to times by 2. And from 34 to 58, we have to add 24. Then if we double the breadth only, you're going to get a rectangle that will look like this. And your area is going to be 120. And your perimeter is going to be 44. Now, once again, to get from the 60 to 120, we need to multiply by 2. But to get from 34 to 44, we need to add 10. And then if we double both the length and the breadth, we end up with a rectangle that looks like that. And our area is going to be 240 centimeters squared, and the perimeter will be 68 centimeters. The relationship between the original area and this area is I need to multiply by 4, and the original perimeter and this perimeter, I need to multiply by 2. Okay, so that's what you should have got for that one. Now we're going to go on to question C. In C, you've got this rectangle that you're starting with. It's 30 meters by 3 meters. I'm going to give you 3 minutes to do the same thing for this one. Okay, so let's go through that question quickly. So first of all, we are working with this shape over here where we have a length of 30 and a breadth of 3. If we multiply those together, you get an area of 90 meters squared, and the perimeter is going to be 66 meters. Now, if we double the length only, you're going to end up with a rectangle looking like this. So it has a length of 60 and a breadth of 3, giving you an area of 180 meters squared and a perimeter of 126 meters. The relationship between this area and the new area is we have to multiply by 2, and the perimeter we have to add 60 to get the new perimeter. Now, if you look at if we double the breadth, we're going to end up with a rectangle that looks something like this. The area is going to be 180 meters squared again. We have over here a length of 30 and a breadth of 6. That gives us 180. And then our perimeter will be 72 meters. Once again, when we look at the relationship from the original area to this area, we have to double it, times by 2. And our perimeter, we're going to be adding 6 to get the new perimeter. Then if we double both the length and the breadth, you'll end up with a rectangle that looks something like that, with a length of 60 and a breadth of 6. When you work out the area, that'll give you 360 meters squared, and your perimeter is going to be 132 meters. If you look at the relationship between the area over here and the new area, you have to multiply by 4, and between the perimeter, the original perimeter, and the new perimeter, we multiply that by 2. Okay, now we're going to take the results that we've got in this investigation and we're going to see if we can draw any conclusions about what happens when we double the length only, the breadth only, or the length and the breadth. Okay, so we're going to use the results to fill in this table over here. In this table, you're going to look for patterns in the results. So I'm going to put them over here so you can see them more easily. These are the results we got in the last investigation that we did. You're going to look for any patterns that you can see over here. So first you're going to look at what happened when you doubled only the length and the effect that it had on the area and the effect that it had on the perimeter. First, looking at the effect that it had on the area, you look and see, was there no consistent change, or was it multiplied by a consistent factor? One of them will be true and the other one will be false. If it's true, you put a tick. If it's false, you put a cross. If you put a tick in this column over here, then you need to put the factor in over here that it was multiplied by. So if it was consistently being multiplied by 2, then you put a 2 here. If it was consistently being multiplied by 5, then you put a 5 here, and so on. Okay, so I'm going to give you 3 minutes to complete this table. Okay, so let's go and see what you should have got for this table. So first of all, we're looking at what happens when you double the length only, and we're focusing first on the effect that it has on the area. So looking over here, we were doubling the length only at the effect that it had on the area. This is what we're looking at over here. You can see that this was multiplied by 2, multiplied by 2, multiplied by 2. So that is a consistent change. So I can put a cross in this one and a tick in this one to say that it was being multiplied by a consistent factor. And the factor that it was being multiplied by is 2. Okay, so every time the area was being multiplied by 2 when we doubled the length only. Now let's have a look at the effect that doubling the length only had on the perimeter. So the perimeter is these ones over here. So here, I was adding 20, I was adding 24, and I was adding 60. That is not a consistent change, so I'm going to put a tick in this one and a cross in this one. It's not being multiplied by a consistent factor, which means that I'm not going to fill anything in over here. Now let's have a look at what happens when we double the breadth only. So now we're looking over here. When I double the breadth only, this is what happened to the area. Every time it was times 2, times 2, times 2. So again, it's a cross in this one and a tick into this one to say that it was being multiplied by a consistent factor, and it's being multiplied by 2. So the consistent factor over here is 2. And then over here, when I'm looking at the effect on the perimeter, I've got plus 20, plus 10, and plus 6. So over here, it's no consistent change again. So there's a tick in there and a cross there. And again, I'm not going to fill anything in here because it's not being multiplied by the same thing every time. And then finally, I'm looking at what happens when I double both the length and the breadth. So that's over here. The area is this over here. So I'm timesing by 4, timesing by 4, timesing by 4. So that's going to be a cross over here and a tick over there to say that it is being multiplied by a consistent factor. And the area is being multiplied by 4. Then looking at the perimeter, I've got times 2, times 2, times 2. So here I've got a cross in this one and a tick in this one. And the perimeter is being multiplied by 2 for this one. So if we look at this over here, I can see when I double the length only, then there is a consistent change on the area. And when I double the breadth only, there's a consistent change on the area that they both get doubled. But there is no consistent change on the perimeter. However, when I double both the length and the breadth, the perimeter has got a consistent change. It is being multiplied by 2, and the area has also got a consistent change, but it is now being multiplied by 4, which is the same as 2 squared. Okay, so now we're going to go and summarize this. How doubling any or all of the dimensions of a 2D shape affects its perimeter and its area. When one dimension is doubled, the area is also doubled, and there is no consistent change that happens with the perimeter. When both dimensions are doubled, the perimeter is doubled and the area is multiplied by 4. In other words, it's doubled twice, once for each dimension that was doubled. Okay, now we're going to go on to an activity. In this activity, you've been given the diagram ABCD, and you're told that it is a kite with AC equal to 20 centimeters and BD equal to 45 centimeters. And you're being asked to calculate the area of ABCD. I'm going to give you 1 minute to do that quickly. Okay, so let's go through that quickly. So to calculate the area, normally you would have to identify what type of quadrilateral it is. In this case, you don't need to because they told you that it's a kite. So we can go straight ahead and use the formula for calculating the area of a kite, which is half diagonal 1 times diagonal 2. Okay, so I have half times, they told me the first diagonal is 20 centimeters and the second diagonal is 45 centimeters. Okay, so now I'm going to go and work that out. So I have half times 20 times 45. That gives me 450 centimeters squared. So that's what you should have got for the area of that kite. Okay, now you need to predict the area if both of the diagonals are doubled. So I don't want you to use the area formula. I want you to use what we've learned about what happens when you double the dimensions of a 2D shape. in order to help you to predict what the area will be if you double both of the diagonals of this kite. I'll give you 30 seconds to do this. Okay, so let's go through that quickly. So over here, what you need to remember is when you double both dimensions of a 2D shape, then the area is going to be multiplied by 4. So I'm going to have my area is 450. So it was 450 before I did any doubling, and I'm going to multiply that by 4 to find out what the new area is going to be. So I have 450 times 4, and that gives me 1,800 centimeters squared. Okay, so without using the area formula, I can work out what the area is after the dimensions are doubled. And then we're going to go in question C and check our answer by using the formula to actually calculate the area if both diagonals are doubled to see if our prediction was correct. Okay, so I'm going to give you 1 minute to do that. Okay, so let's go through that quickly. Right, so over here, I'm going to use the area formula for a kite again. So I have area is half diagonal 1 times diagonal 2. Right, so if I double the diagonal 1, it changes from 20 to 40. And if I double diagonal 2, it changes from 45 to 90. Okay, so now I have half times 40 times 90, that gives me 1,800. Which is the same as what I got over here, where I multiplied by 4, using what I know about what happens to area when you double the dimensions of a 2D shape. And that's what happens when we change the dimensions of 2D shapes and look at the effect that it has on the area and perimeter of those shapes. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.